Okay, so this lesson is for section 2.2 in our textbook. We're going to be solving all kinds of different equations, but we're going to focus on absolute value, radical equations, and equations using square roots, nth roots, so cube root, fourth root, that kind of thing. And then also we're going to solve equations that end up looking like quadratics if we kind of manipulate them. Okay, so the first thing I want to do is talk about a little bit of review here. So I have the absolute value of x minus 4. And a question here that when can it be written as x minus 4? So when do you just leave it alone? And when do you rewrite it as the opposite of x minus 4? So think back to what absolute value does. So if x minus 4, if this inside is positive, so when x minus 4 is positive, then the absolute value of x minus 4 is written as, so it's equal to just x minus 4. When x minus 4 is negative, in other words, when the inside of this is a negative value, then we write the absolute value of x minus 4 as the opposite of x minus 4. Okay, so that's the basis basically for when we solve absolute value. And I know here we've got a pretty basic absolute value equation. You've seen these since, Algebra 1. But we want to use the definition of absolute value and the algebraic definition of it in order to solve these. So again, if this is positive, then 5x minus 3 is going to equal 5x minus 3, and it's going to be written the same. It's going to equal 12. If this inside is negative, then we rewrite that as the opposite of 5x minus 3, and we set that equal to 12. So there are my two cases, right? And I solve these just like normal. So I have just a basic linear equation here. And I get two unique solutions. Okay, so again, you want to make sure you really understand this concept, that you have one case where the inside is positive, you leave it alone. You have another case where the inside is negative, and you make it its opposite. So in example number 2, it's definitely a little bit more difficult, right? We have the absolute value bars showing up on both sides. But again, we just want to apply the definition of absolute value. So let's make our cases here. Let's say that the inside of this is positive, right? So I'm going to rewrite that as just x squared plus 5x. The inside of this could also just be positive, so I'm just going to solve that one like normal. Now let's say that the inside of the left-hand side was negative. So I'm going to rewrite that as its opposite. And that the inside of this side over here on the right was also negative. Well, and look at what ends up happening here. You have a negative on both sides, which they'll cancel anyways, and it'll leave you right back to this case. Okay, so they're both going to be positive and both set equal to each other. Now let's say they are not equal to one another, and let's say that they're opposites. So in other words, x squared plus 5x is still positive, so we rewrite it like that. But the other side, the right-hand side, let's say that this is negative. We are left with this, right? Which is different from our first case. Now, if we had chosen to make the left-hand side negative, then the right-hand side would remain positive, and we'd get the same thing. These two are equivalent equations, right? It's just distributing the negative over to here and taking out from the right-hand side, it leaves you with this bottom equation. So really, the only two cases that you need to set up here are ones where they are both equal to each other, right? The case where they're equal to one another, and the case when they are opposite of one another. So these are tricky, but can be solved pretty much just like normal. So we have now a quadratic that we're going to solve. I'm going to subtract 3x. We have x squared plus 2x minus 16 equals 0. And since this is not factorable, I am going to use the quadratic formula. So I'm going to have negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. So I'm going to go ahead and solve that and pause it. Okay, so you can see my solution here, x equals negative 1 plus or minus root 17. I don't actually need to check this answer back into my original equation, which would be all the way back up here. The reason why I don't need to do that is because I didn't square either side of the equation, so these are not extraneous solutions. So I don't need to check that, but you could, I guess, if you really wanted to. Now on the other side, it's going to be a little bit easier to solve this equation because I believe this one is factorable. So when we Bring this over here. I just need two numbers that would multiply to 16 and add up to 8. And I end up with one solution here of -4. So my 3 solutions here are right there. Okay, now the next section here is solving equations using nth root properties. Okay, so off to the side here, we're going to come back to this little part here. I just want to solve number 2 here by getting x by itself. So if I have x minus 1 to the 4th power equaling 7, I'm going to take the 4th root of both sides. So if I take the 4th root of both sides, I have x minus 1 equaling 4th root of 7. I'm going to add the 1 over to the other side. And I want to make sure, I should have put it up here too, but this is actually 2 unique solutions because I can have positive or negative 4th root of 7. So x here is going to equal 1 plus or minus the 4th root of 7. So we're noticing that when we have an even power, then we get 2 answers that are possible, right? Positive or negative. Now, we could also get no solution, of course, or just 1 if it was 0 on the inside of this. If that was equal to 0, then we would just have, 1 plus or minus the square root of whatever, if n is even. This is just going to be 0, so it's only one number. But if it is negative on the inside of that, then, of course, like this problem here, we get no solution. So if we took the 4th root of both sides, we end up with x minus 1 equaling the 4th root of -7, which has no real, these are complex solutions, so we'd actually stop here. So it has no real roots here, because again, a root is when it crosses the x-axis, so this particular function here would never cross the x-axis because it doesn't have any real roots. Okay, now moving on to the 4th problem here. Problem number 4 here, if I want to isolate this x, I need to divide by 3 first. And then I'm going to take the 5th root. Now when you take the 5th root here, you will get a real solution because it is possible to take the 5th root of -16. So it's going to be a negative number, but we do end up with, this is a real number, as opposed to here when we take an even root, we cannot end up with a real number if it's a negative number on the inside. When it is an odd root, though, we can end up with a real number, but it's only one real solution, right? It's only one real solution because that's the only case where you're going to end up multiplying an odd number of negative numbers to still get a negative number. So if n is odd, there's only one solution. If n is even, then you possibly get 2 answers like we did in the very first example, right? We get 2 real roots here. Or you could get 1, and I did talk about the case where you get 1 root, and that's if, again, the inside of this is 0, because then it kind of goes away, and then you're left with just the number out in front. Or you could get no solution, which is when you get a case where you have non-real solutions because your inside of your radical is negative. All right, let's move on to radical equations. So we're kind of seeing all different types of equations here, and I just want to get you used to seeing, being able to solve different types of equations when they're thrown at you, because we're not always just going to give you one type of equation. So the rules with radical equations is you always want to isolate a radical. You have to isolate a radical and then square both sides. But once you square both sides, you actually introduce extraneous solutions. So you need to check your final answers to make sure that it fits inside your domain and it actually satisfies your original equation. So the first thing I want to do here is isolate one of these. I'm going to isolate this guy because all I have to do is add it over to the other side. It doesn't really matter which one you choose, but I'm just doing that because it has an opposite sign. So I have 2y minus 3 plus root 3y minus 2 equaling on the other side now, once I move it, 3 root 3y plus 3. All right, now I'm going to square everything on both sides. The right-hand side, no problem. That's pretty easy to, simplify here. The left-hand side, though, does require a little bit more work. So it is a little bit more work, but I want to show you kind of a shortcut here as well when you're squaring something. So let's start with like x plus 3 squared. Okay, if I were to FOIL that out, I would get x squared plus 6x plus 9. So there's a pattern here when you FOIL this. The first term is just squared, right? This middle term here comes from multiplying the two terms and then doubling that. So 3x times 2 gives me 6x. The last term is just the second term squared. Now let's say I made that 2x plus 3. So again, I just take the square, sorry, so that should be 2x plus 3 squared. I take the first term and I square it, so I would get 4x squared. I would then, for the middle term, multiply these two, get 6x, and then double it to give me 12x. So again, I multiply these two together, and then I double them. And then the last term is just the second term squared. Okay, so let's apply that to this lot more complex looking square. So it's a perfect square, and I know that I can just square the first term, right? The first term squared is going to be just 2y minus 3. For the middle term, I'm going to double this multiplied by that. Okay, so it's going to be 2 times, I need more room here, so I'm going to erase, 2 times the inside of that radical should be 2y minus 3 times 3y minus 2. The very last term is going to come from squaring this second term here, so that's just going to be plus 3y minus 2. Sorry I'm switching colors so many times, but okay, now I'm going to write that right hand side again. We already know what that is. Okay, so now I'm left with just one radical, right? So instead of multiplying that out, don't waste your time multiplying that out, because we're going to have to do some more stuff here anyways and square that. Just leave it like it is and just simplify everything else and get it to the other side. So I'm going to move these terms and these terms, move them to the right hand side. So now again, I get back to step 1. I have to isolate the radical. So you keep isolating your radical and squaring until you're left with no radicals. So I now have this inside I'm going to keep like that. If I bring over these, let's see, these are going to cancel out. So I have negative 2y and add 5, 8. So negative 2y plus 8. Okay, now at this point you can do one of two things. You could just go ahead and square the whole left-hand side and the right-hand side, because you can square this when it's just a number attached to the radical, because it's 2 times that. So you can square this, okay? That would follow all algebra rules. Or you could also divide out the 2, because this is divisible by 2. That would be easy to do that here. If that was an odd number, though, or something that would not nicely divide on the right-hand side, I would not move it. I would just go ahead and square it. So I'm going to divide by it, though. Just remember that if you don't divide by it, you're going to have to square the 2, so you would end up with like 4 here. But I am going to divide it so that I have on this side negative y plus 4. Okay, so I'm going to erase this and write that as negative y plus 4. And then I'm going to go ahead and square both sides now. So when I square both sides, I'm left with 2y minus 3 times 3y minus 2 equaling this term here squared, right? So squaring both sides, that's going to give me y squared minus 8y plus 16. Now it looks like I'm going to have a quadratic, and I'm just going to simplify the left-hand side here. So I get 6y squared minus 4y minus 9y, so minus 13y plus 6 equaling y squared minus 8y plus 16. So I subtract over, and let's see, I'm left with this quadratic. I can still factor out a 5. And now I'm looking to factor the inside here. I need two numbers that multiply to negative 2 and add up to negative 1. So that'll be negative 2 and positive 1. And I get 2 solutions here. Okay, so it took a long time to get those 2 solutions, but you can't just trust both of them, all right? What you need to do is check to see if you have an extraneous solution in here. So because we had to square stuff, you're always going to have to check in a radical equation whether or not you have an extraneous solution. So we're going to plug in 2 and negative 1 back into our original equation here. If one of those gives us a negative radical, then that's not possible, right? Because we can't have part of our answer being, or part of our equation being imaginary. So we're going to just test real quick. So if I plug in 2 here, I get a positive answer, because 4 minus 3 is 1. If I plug in 2 here, I still get something positive. If I plug in 2 here, I still get something positive. Now, if I plug in negative 1, though, the first radical here becomes negative 5, so that's not okay. So clearly, right away, negative 1 is not a solution. 2 must work in the original, so 2 is my final answer here. Okay, in this next section, we're going to be working with equations that basically become quadratic equations when we recognize a pattern. So over here, it says one exponent will be double the other and you'll have a constant term. So if you take a look at each of these problems here, we have an exponent that's double the other, and so 8/5 is the same as 4/5 multiplied by 2. Negative 1 times 2 gives me negative 2. So each of these exponents here are double the other, and then you have a constant term as well. So you want to be able to recognize when you have this kind of equation, because you're going to just treat it like a quadratic. Okay? So, for example, in this first example here, if I subtract the 12 over here, this is a factorable quadratic. Okay? If I were to treat, let's call it t. Let's let t equal x squared. Okay, so if I do that, then this is equivalent to t squared, right? Because if t equals x squared, then t squared equals x to the 4th power. So I'm just substituting in letting t equal x squared. So I have t squared minus t minus 12 equals 0. So if I factor this, I end up with t minus 4 and t plus 3 equaling 0. And then I'm going to just substitute it back in, x squared minus 4 and x squared plus 3 equals 0, so that I have two equations to solve, x squared minus 4 equals 0 or x squared plus 3 equals 0. And I end up with two distinct reals here, positive and negative 2. And over here, this produces non-real solutions, so this is not going to be part of my real solutions here for this particular equation. So my final solution is positive and negative 2. Okay, now in number 9, let's let, again, t equal x squared. So we just take the base, basically your middle term here is going to be what you're going to allow t to be. So t equals x squared, and we're going to rewrite this as t squared minus 8t plus 8 equaling 0. So this one's not factorable, so if it's not factorable, let's just use the quadratic formula. So we're going to plug that right into the quadratic formula. Okay, so I actually just went ahead and I put this in the quadratic formula for this particular equation. Remember, we did substitute in a value. Here we let t equal x squared. So when I simplify this, I end up with 4 plus or minus 2 root 2. So that's what t equals. Now I want to substitute back in and let x squared equal 4 plus or minus 2 root 2. So I now have two different equations here that I can solve. X squared is going to equal 4 plus 2 root 2, or x squared will equal 4 minus 2 root 2. Okay? So this branches off into this, into two separate equations. Now when I take the square root here to solve for x, if I take the square root of the right-hand side, I end up with two solutions here as well, positive or negative 4 plus 2 root 2. And here as well, if I take the square root, I end up with positive or negative 4 minus 2 root 2. So we actually have four distinct real solutions. X can equal positive or negative 4 plus 2 root 2, and the square root, sorry, of 4 plus 2 root 2, and positive or negative square root of 4 minus 2 root 2. So this one is a little bit funky because you probably haven't seen many solutions where you have a radical inside a radical, but these are real numbers, so they are part of your real solution. Okay, if you want to pause right now, you can try 10 and 11 on your own. Make sure you make substitutions, let t equal this term here, your middle term, and then from there you're going to turn it into quadratic and go ahead and solve. So you can pause it here and try that, and then come back and replay. Okay, in problem 10, I'm going to let t equal x to the 4/5. Therefore I have 3t squared minus 5t minus 12 equaling 0. And this one is factorable, so I'm going to factor this by splitting the middle term. So I have 3t squared minus 9t plus 4t minus 12 equaling 0. So factor out 3t, factor to 4. I end up with 3t plus 4 times t minus 3 equaling 0. Now in the problem, I think number 8, when I did this, I just right away substituted the t value back in. You could actually solve this for t here So if I solve, I would get t equaling negative 4/3 and t equaling 3. And then I would now substitute in the x to the 4/5 power. So it doesn't really matter where you do it. I'm going to do it now though and say let this side of the equation now become x to the 4/5 equaling negative 4/3 and x to the 4/5 equaling 3, right, just by substitution, because I know that t is supposed to equal x to the 4/5. And then if I solve here, I'm going to take this to the 5/4 power. So that would allow me to get x alone, right, x to the first power now, equaling negative 4/3 to the 5/4 power. Now this is a non-real number. This is not real, so this is not part of our solution. You can just verify that using your calculator actually if you want to. Over here on the other side, we can't take negative to an even denominator, so this is not going to produce a real solution. But if we multiply here or if we raise it to the 5/4 power, we end up with x equaling 3 to the 5/4 power. And this is a real number because it's positive raised to a rational exponent. Okay, now in problem number 2, let's let let's let t, or whatever variable you want to use, anything you want to use, negative first power. So if we rewrite this, we now have 6t squared minus t minus 2 equaling 0. I believe this one is also factorable, so I'm going to split this into 6t squared minus 4t plus 3t minus 2, and factor out a 2t, and factor out a 1 here, and I get 2t plus 1 and 3t minus 2 as my factors, linear factors for this quadratic here. And now I solve, and I have t equaling negative 1/2 and t equaling 2/3. Okay, so now I'm going to substitute back in x to the negative first power. So x to the negative first is equal to negative 1/2, and x to the negative first is equal to 2/3. So solving for x here, you can think of this either way. You can raise this to a negative first power if you wanted to. It'll produce the same results. If you also look at this as 1 over x equaling negative 1/2, then this is just the reciprocal, so x would equal negative 2. And the same thing here, we think of that as 1 over x equaling 2/3, then x should equal 3/2. Okay, this is the end of lesson section 2.2, part 1.